Okay, Chem 8, welcome to the third video in the sequence on reviewing for the common exam. And what we're going to do here is practice identifying bonds that are polar. So we're going to answer the question for each of the molecules that I drew in this diagram, which is which bonds are polar and how you determine that. All right, well, you guys need to remember that I've already produced some videos that review this issue that were assigned to you a while ago. I know a lot of you probably didn't do them. So if that is the case, you need to just go ahead and pause out of this and go back to those video assignments and get that work done, because this is absolutely critical that you understand these concepts. So moving on here, which is basically summarizing what you should be able to do. All right, what I have on the top of the diagram are two legitimate molecules utilizing actual atomic symbols off the periodic table. I see that on the structure on the right, or left, I mean, that I left out the electron pairs on the bromine. So let me just put those in quickly, so that they don't look funny to you. Okay, so how do we tell? All right, first off, let's just review quickly the definition of electronegativity. So this is the attraction an atom has for the bonding electrons when it's in a bond with another atom based on differences in electronegativity. And I produced a video that had a periodic table that had electronegativities in it. And then I went through a whole bunch of different examples. So one of the main things that, I guess, points that you can use to help you with analyzing different molecules is to remember that pretty much all of the atoms on the periodic table, this is not an absolute truth, but most of the atoms on the periodic table have differences in electronegativity. So just about as long as the two atoms in the bond are different, then that bond is going to be polar. So for example, if we go through the molecule on the left first, if we look in the middle, we see that there's a CC bond. And this bond is defined by two atoms that are identical. So we would say that the CC bond is nonpolar, because the two atoms that are on either side of the bonding electrons are the same. So you've got two atoms that have the same electronegativity. On the other hand, if we look at the CBr bonds, all right, these two atoms are different. They definitely have a difference in electronegativity. If you go back to that other video and you look at the chart, or you've memorized your trend, which you should do, the Br is far to the right from the carbon. They're going to have a different electronegativity. So what does that mean? It means this bond is going to be polar. All right, and then not to ignore it, we also have a CH bond here. Now, here's the thing. The electronegativity is pretty close for both of these atoms, and you'll see that when you look on the table. However, on the common exam, they're not going to give you electronegativities in terms of numbers. There's no way that's going to happen. So you need to apply rigorously the trend, which you already know. The H is far to the left of the carbon is far to the right of the hydrogen, and therefore there has to be a difference in electronegativity. Therefore, based on that, we would characterize this bond as being polar. All right, I don't need to do these guys here because we already did it. All right, now we're going to move to the right. And again, we can quickly move through this molecule. This CH bond right here, because H appears way on the left of the periodic table, carbon is way on the right of the periodic table, comparatively speaking. So this bond would be polar. All right, then we have in here, let me brighten this up a little bit so it's not obvious. We have the CC bond. Both the C's are identical, and based on that criteria alone, we would call this bond nonpolar, because both of the atoms that are on, that are sharing these electrons are the same. See, I misspelled that. All right. And then let's see, change the color again. Here we have a carbon double bonded to an oxygen. Oxygen and carbon definitely have differences in electronegativity. Oxygen falls to the right of carbon on the periodic table. Carbon is to the left. So this would be an example of a polar bond. No question about it. And then last but not least, it'll be this relationship right here. Carbon bonded to the Cl. Again, carbon and Cl are separated by quite a bit of distance on the periodic table. Cl is far to the right and down, and the carbon is up and to the left, and so this would be characterized as a polar bond. All right, now let's look at an example that has atoms that have been substituted with alphabetical symbols. So let's take a look at the molecule that's over here. And, there's nothing to freak out about. You can see that it represents a signal, or excuse me, it represents symbolically a compound. The dashes, the same as everything that we just did above, mean covalent bonds. You can see the A's that are in the molecule here have unshared electrons for a total of 8 around them. And the M here could, who knows what it represents, but most likely, since there's no unshared electrons, is probably, like a hydrogen or something. Anyway, the letters represent elements. And you analyze this compound exactly the way, that we did the ones above. So if I circle the AB here and answer the question, is it polar or not? Well, they're two different atoms, and by that criteria alone, they exist on a periodic table where, in fact, the vast majority of elements have differences in electronegativity, so we would characterize this as being polar. All right, by that criteria alone. And then, again, in the middle of the molecule, look at this, we have BB. So this particular bond has identical atoms on both sides of it, so we would characterize this bond here as being nonpolar. Again, now, I'm not overthinking this, right? You don't want to overthink this. Here we have a B and an M bond. Again, what I've taught you, the vast majority of atoms on the periodic table have differences in electronegativity, and these two atoms are different. And therefore, they're not going to be sharing the electrons in this bond the same. So this would be considered a polar bond. And lastly, last but not least, let me find a different color here. We have this BD bond right here. And again, using common sense and the knowledge that the vast majority of elements on the periodic table have differences in electronegativity, and the fact that these two atoms are different means that they're going to have different magnitudes in which they're sharing these electrons, and so this bond is going to be polar. Okay, and with that, I'm going to go ahead and conclude the video.